time and eliminate the variable. You want to arrive at two equations in two unknown, like you used to be doing before. So by eliminating a variable from two of those, then you will solve for the two remaining variables. That is the quickest way to go about and do it. Some of them are easier than this because some of them they give you probably some of those equations with two variables. But these here, this one here, you have all three of them, you have three equations in three unknowns. So a good thing to do here then is to inspect it. And if you do a little inspection here, we see that I would call this here equation 1, 2, and 3 for convenience. If you don't want to do that, that's fine. If you want to do it for convenience, that's okay, or any other method you want, that's fine. But I'm going to do this here for convenience, because I already see that if I add 1 and 2, I will eliminate z. That's why I'm going to be doing that. I will put 1 here, x plus 4y minus z equal to 20, and 3x plus 2y plus z equal to 8. So right away there, I see that I will eliminate my z, and then I have 4x plus 6y equal to 28. So right away then, I could call this here, this is 1 and 2, I could call this here equation 4. I'm just doing that for convenience. If you don't want to do it, that's fine, but this is for convenience. Now, what I'll do next, I will take equation 1 and 3. I'll take equation 1 and 3, and again, I will eliminate z. So I will eliminate z here. So 1 and 3, let's see, 1 here is x plus 4y minus z equal to 20, and 3 is 2x minus 3y plus 2z equal to minus 16. So now what I'll be doing here then, I find that by inspection, I see that if I multiply this one here, 1 by 2, and I add it to 3, I will knock off the z. Alright? That's what they call for a lot of inspection. And sometimes if you use the correct method, you can either make these things easier or harder. You don't want to introduce fraction and so on. If it doesn't, it's not called for that. So then I'll multiply this here by 2. I'll do that and add it. So that gives me here, this implies that this is going to be 2x plus 8y minus 2z equal to 40. And this one I rewrite it just below it. It's 2x minus 3y plus 2z equal to minus 16. So now I will go ahead and just do this one here. So if I do that, I get 4x here, and this gives me plus 5y. This cancels off that, and this gives me equal to 24. So here now I have equation 4. I'll call this here 5 for convenience, and those are the two I will use. So I'll put those two together. 4x plus 6y equal to 28, and I use here 5, 4x plus 5y equal to 24. So right away I see here, with these two here, if I multiply one of them here by minus 1, I will knock off the x. If I multiply this one here by minus 1, and I add, I'll knock off the x, and then I will end up with just y. So then, if I go ahead and do that, I will have minus 4x minus 6y equal to minus 28. All right, and then I'm multiplying everything by minus 1. Then I have here 4x plus 5y equal to 24. So then I have this here cancel off that, and here I have minus y equal to minus 4, and this gives me that y equal to 4. So I have y equal to 4. So since I have y equal to 4, then I could go back and solve for x here. I have two equations and two unknown here. All right. I know what y is. So I'll go back and use back substitution. All right. I'll go back and use back substitution. And if I get I use this one here, then I get 4 times x plus 6 times 4 equal to 28, and then I get 4x is going to be equal to 28 minus 24, which is equal to 4. Therefore, x equal to 1. So x equal to 1. So right away, class, we have y equal to 4, x equal to 1. Take these two and go back and do some back substitution up here. All right? You want to do it systematically. When I say systematically, it's very easy to get confused with these equations. And you don't want to, make it harder than what it is. Your idea is to make it more simple. But those things normally happen quite a bit. So then I would go back then and use this one here, x plus 4y minus z equal to 20. I know what y is. This is 4 times 4. I know what y is. This is 1 minus z equal to 20. And then I will solve this one here. This will give me 1 plus 16 minus z equal to 20. And this is 17 minus z equal to 20. Minus z is equal to 20 minus 17. Minus z is equal to 3, z is equal to minus 3. So here we have our solution set. It's going to be, put them in here in this bracket. It's going to be x equal to 1, y equal to 4, z equal to minus 3. So this here is our solution, our triple. Our triple is 1, 4, minus 3. But if you are not sure that this is the correct answer, you can go back and take x equal to 1, y equal to 4, z equal to 3, and substitute it in there. Make sure you get true statement. Because remember what you were doing before, that when you were checking to see whether those triple are solution, you were substituting and see that you get a true statement. So then, I will go ahead and put 1 here, plus 4 times 4, minus 3. Minus 3, minus 3 equal to 20. And this is going to be 1 plus 16 plus 3 equal to 20. And you get 20 equal to 20, and it's true. So that one is true. You can check the rest if you want. It's supposed to give a true statement. So is that all okay then? Some of them would be easier than that. This one here is a little bit tougher than the other because some of them you'll have, instead of 3 variables, you'll have 2. This one here was all packed up with variables. So go ahead and do the rest. Let's go ahead and do a worded problem. Those worded problems, as I mentioned, they are very important if you intend to go in medical field and so on. And things like that, you might be able to solve a problem like this, or you may have to solve a problem like this. Let's see one of these problems what he asks about here. It says, and this here is applying system of 2 equations in 2 unknown to real life situation, real life problem. So let's go.